Hey there guys, welcome to the video. My name is Pushpinder Gill. In this video, we're going to be talking about matrices. So this is the first video on matrices. So in this video, we're going to be talking about the introduction to the matrices. So, I'm just going to be explaining matrices to you as if, you don't know anything about it. So starting from a very simple statement, let's suppose I have this statement that, John, let's say John and Jesse. Let's suppose this is a very simple statement. John and Jesse, they together have, let's say, John has 15 notebooks and Jesse has 20 notebooks. So, I'm talking in terms of notebooks. Now, you can actually represent this in terms of a matrix, right? So, or let's suppose if I try to put that in a tabular format, I'll get that this is John here and this is Jesse here, and these are the number of notebooks that they have. That is, John has 15 notebooks and Jesse has 20 notebooks. So you can actually represent this in terms of a matrix that is 15 and 20 is the number of notebooks that John and Jesse have. Another thing is, let's suppose John has 15 notebooks and Jesse has 20 notebooks, and John has 7 pens. Let's suppose this is notebooks and this is pens. John has 7 pens and Jesse has 8 pens. Now, how do you represent that in terms of tabular form? So let's suppose I can say that you have John here and you have Jesse here, and this is your notebooks and this is your pens, and you're going to represent that information like this here. So this is 15, this is 20, this is 7, and this is 8. And let's suppose if I want to put that in terms of a matrix, I'll say that let's suppose this is the matrix wherein this is actually a matrix where this column represents the number of notebooks and this column represents the number of pens, and this represents John and this represents Jesse. Right? So that means at the end of the day, a matrix is nothing but it's kind of a way to represent information, and it's very, very crucial. If we go in the future videos, we're going to be talking about various applications of matrices, but right now all I want to tell you, it's very, very important for you to understand that. So you can actually represent a piece of information in so many different ways. Let's suppose I want to represent this piece of information. Let's suppose that the information is that there are a total of 4 points with me. Let's suppose the points are 2, 3 and 5, 6 and 7, 8 and 1, 9. So let's suppose these are the 4 points and I want to represent in terms of a matrix. So I can actually do that in a lot of ways. I can say that this is one of the matrices, 2, 5, 7 and 1, and I have 3, 6, 8 and 9. I can also represent this as 2, 5, 7 and 1 and 3, 6, 8 and 9. So in this, I've actually represented this column as the x coordinates and this column as the y coordinates. In this, I've represented this row as the x coordinates and this row as the y coordinate. So there are so many different ways I can actually represent the same piece of information in a different format. So right now you must have understood that every matrix has certain number of rows which are denoted by m, and it has certain number of columns which are denoted by n. So the total number of elements are actually given by m into n. So you can clearly see I have 4 rows, so the value of m here is 4, and I have 2 columns, and the total number of elements are 8, and you can clearly count it up: 1, 2, 3, 4, 5, 6, 7, 8. The total number of elements over here are 8. So this is actually a matrix here which has m rows and n columns, and the total number of elements are given by m into n. Now let's go ahead and properly and formally define a matrix. So what do you mean by order of a matrix? Right? So we're going to define the order of a matrix here. Now what do you mean by order of a matrix? So let's suppose a matrix has m rows and it has, let's say, n columns. Right? So we have a matrix with m rows and n columns. So the number of elements are going to be equal to m into n. So the number of elements are going to be equal to m into n, and the matrix is going to look something like this. Let's say this is our matrix here. So we write m into n here, where m represents the number of rows, n represents the number of columns. and each element, so this is, let's suppose, the first element, it belongs to the first row and it belongs to the first column. That is how we represent this element. Now the next element is, it belongs to the first row but it belongs to the second column. The third element belongs to the first row and it belongs to the third column, and so on. So the last element in this row is going to belong to the first row and it's going to belong to the last column, which is the nth column, because there are a total of n columns there. The second element is going to belong to the second row, first column, second row, second column, all the way till second row, nth column. And over here, the last row is going to belong to the nth row but the first column. Similarly, the last and the last element is going to belong to the mth row and the nth column, right? So that is there. And let's suppose if I want to say that, if I want to find out any particular element which is belonging to the ith row and the jth column. So this is how you kind of define a particular element in this matrix here. It can belong to, let's suppose, this is what I want. It's the ith row and the jth column. And one thing that we have to understand, that the ith row which is there, this value of I is always going to be greater than or equal to 1, because you cannot have a fraction or a negative number of row. It will always be greater than or equal to 1, and it will always be less than the total number of rows or equal to the total number of rows. Similarly, j over here has to be greater than or equal to 1, and it has to be less than or equal to the total number of columns. And again, one more thing, this I and j are always going to be integers. You can't have 1.5th row or 1.6th row. And actually, in fact, the better way of calling this, they're always going to belong to natural numbers, because you cannot have a negative row, you cannot have zero number of rows. You'll always have a specific natural number of rows, right? So I suppose you're understanding my point over here, and this is how you represent a column here in terms of this there. And this m into n is actually known as the order of a column. We wanted to start, order of a matrix. So let's suppose if I have a matrix which is of the order 3 into 2, that means it has 3 rows and 2 columns. That means it's going to have 3 rows, that is 1, 2 and 3, and it's going to have 2 columns, 1 and 2. So this is going to be a matrix with an order of 3 into 2. So the order of the matrix is actually equal to m into n. So suppose you're getting my point over here, guys, and let's say if you were to talk about a question, let's suppose a matrix has 8 elements. Let's suppose it has 8 elements. So what all possible orders it can have, right? So what all different possible orders it can have. Now we know that the number of rows and the number of columns is going to be equal to 8. So there can be 1 row and 8 columns. There can be 2 rows and 4 columns. There can be 4 rows and 2 columns, or there can be 8 rows and 1 columns. So these are the 4 different ways in which the matrix can be there. This would be represented as 1 row and 8 columns. That means we're going to have a simple 1 row and 8 columns. That means 1, 2, 3, 4, 5, 6, 7, 8. That is how this is going to look like. This over here is going to look like 2 rows, that is 1 and 2, and 4 columns, that is 1, 2, 3, 4, 1, 2, 3, 4. So this is how this is going to be, right? So suppose you're understanding this point over here, guys. Pretty easy thing, but very, very important for you to understand. Now let's go ahead and classify different types of matrices. Now that is something which is very, very important. So the first matrix that I would like to define is known as the column matrix, right? So what do you mean by a column matrix? A column matrix is a matrix which has only one column, right? So a column matrix is a matrix which has only one column. So this over here, 0, 1, 2, 3, this actually has one column. That means this is a column matrix. However, this over here is not a column matrix because it has 2 columns. So a column matrix, it's actually a matrix with only one columns. And the general form, so we denote a matrix, let's suppose by A. Let's suppose matrix A has, this is the way we denote every element of it. So for a column matrix, the number of columns is always going to be equal to 1. So that means for a column matrix, the order is always going to be equal to m into 1, because the number of columns is always going to be equal to 1. The next type of matrix that I would like to classify, it's known as row matrix. So what's a row matrix? Just like the column matrix, which has only one column, in row matrix it is going to have only a single row, that is only one row. So this is how row matrix looks like. It only has one row. That means for a row matrix, each element, the order of this matrix is going to be 1 into n, where this is actually equal to 1. Now let's talk about another matrix which is known as a square matrix. Now what is a square matrix? In a square matrix, the number of rows is actually equal to the number of columns. So the number of rows are actually equal to the number of columns, which means the value of m is actually equal to the value of n, which means a square matrix can be defined as the order of the square matrix is going to be m into n, or is going to be n into n, whichever you want to take it, as m is actually equal to n. An example for a square matrix would be 1 2 3 1 2 3 1 2 3. So you can clearly see it has 3 rows and it has 3 columns. Sorry, it has 3 rows and it has 3 columns. That means it's actually a square matrix of order 3 by 3. Right? So I suppose you're understanding this point over here. And one more important thing for a square matrix is that the elements where the number of the row and column, the number of row and the number of column are equal. This row, this element, this element, this element. These are the one which constitute the diagonal of a matrix. Right? I'll explain that again. In a square matrix, where the where the order of row and the order of column, so let's suppose this is a square matrix where you have a1 something, let's suppose a1, this is the first row and the first column, this is the first row and the second column, and so on, and similarly you have so on here. The elements constituting a11, a22, a33 and all the way till these elements are going to constitute the diagonal of a matrix. Right? So I suppose you're understanding this point over here, guys. This is known as a square matrix. Now, since we're talking about diagonals, let's talk about what is known as a diagonal matrix. In a diagonal matrix, what we're gonna have is, if all the diagonal elements, all the non-diagonal elements are equal to 0. So in a diagonal matrix, all the non-diagonal elements are equal to 0. So it's actually only a square matrix. Okay, so we are talking about square matrix only. We're not talking about any other matrix. So in a square matrix, if all non-diagonal elements are equal to 0, that matrix would be called as a diagonal matrix. So let's suppose if I want to talk about this here, so let's suppose 1 2 and 3, and you have 0 0 0 0 0 0. So this would actually be a diagonal matrix because all the diagonal elements are there, and all other non-diagonal elements are 0, right? So if all other non-diagonal elements are 0, then it will actually be equal to a diagonal matrix. So if I want to justify this this matrix over here, that if there is a matrix with an order of, let's suppose, m into m, then if all the elements are equal to 0, provided I is not equal to j, right? Because these elements should not be 0, all the other elements should be equal to 0. Now let's talk about another type of matrix, which is known as the scalar matrix. Now what is known as the scalar matrix? In a scalar matrix, if all the diagonal elements, it's actually a kind of, it's actually a subcategory of a diagonal matrix. If there is a diagonal matrix whose all the diagonal elements are equal, right? So that would be known as a scalar matrix. So let's suppose if I have this matrix, instead of having instead of having, let's say, non-equal elements here, if these elements are equal to each other, that means this is going to be a scalar matrix. Let's show you another example where I have this thing here. So in this case, it's a type of a diagonal matrix. So if suppose you already know what's a diagonal matrix is, it's a type of a diagonal matrix where all the other non-diagonal elements are 0, but the diagonal elements are equal, right? So suppose you're understanding this. So if I want to define, generalize this, let's suppose I have a matrix of order m into m, and all other non-zero elements are 0, and the elements which are non-zero, the elements which are non-zero which fall on the diagonal, they are actually equal to some specific number, right? So I suppose you've already know the example of these the example of these scalar matrices. Now let's try to find another type of matrix which is known as the identity matrix. Now what do you mean by an identity matrix? It's actually a kind of a square matrix where all the diagonal elements are equal to 1 and rest of all are equal to 0. So it's kind of a square matrix where all the diagonal elements, so all the diagonal elements are equal to 1. So the diagonal elements are equal to 1, and you have your all the non-diagonal elements, so non-diagonal elements are equal to 0. So if let's suppose if I want to define a identity matrix, this is actually an identity matrix, this is actually an identity matrix, and this over here, it's actually an identity matrix, right? So this is also an identity matrix. So if I want to define a kind of let's suppose a matrix, a square matrix, where all the diagonal elements are equal to 1 and all the non-diagonal elements are equal to 0. So this would be an identity matrix. Now the last type of matrix which I would like to define is actually a zero matrix, which is actually a type of a matrix where all the elements are equal to 0. It need not to be square or need not to be a non-square. It's all type of matrices where all the elements are 0. That would actually be a zero matrix. So you can clearly see that these matrices, all the elements are 0, which means that this matrix is going to be known as a zero matrix. Fine. So if I were to kind of talk about the classification of these matrices, so let's suppose if I want to talk about the classification of these matrices, so you're gonna have your row matrix, you're gonna have your column matrix, and in that you're gonna have your square matrix, and you're gonna have your zero matrix. In square matrix, you have so many different types of matrices. You have your diagonal matrix, wherein you can have all the non-diagonal elements are 0. You have your scalar matrix, in your diagonal matrix only you have your scalar matrix, where all the diagonal elements are constant and everything else is 0. And only in square matrices you have your as identity matrix as well. You can either call it here or you can also call it here. Let me write it here. You have your identity matrix where your diagonal elements are 1 and rest everything is 0, right? So that is there. I suppose you're understanding this point over here, guys. And let's move forward to the next thing, that is actually the equality of matrices. Now that is actually a very, very simple thing. That is, how do you say, let's suppose if I say there are two matrices, matrix A in which all the elements are defined as this, and matrix B where all the elements are defined as this. Now how do you say A is equal to B? There are specific conditions to be followed. So the first condition that has to be followed, that these matrices have to be of the same order, which means the number of rows and the number of columns. Let's suppose this is m of m into n, and let's suppose this is actually equal to p into q. So m should be equal to p and n should be equal to q. There have to be of same order. And the next thing which is very, very important for matrices to be equal, that each element of A, so each element of A, that's what I want to talk about, each element of A is actually equal to the corresponding element of B, right? So it has to be equal to the corresponding element of B. So let's suppose if I want to talk about this, so let's suppose 1 2 3 4 5 6. This, if let's suppose this is matrix A and 1 2 3 4 5 6 and this is matrix B, they will not be equal because they are not of the same order. And let's suppose if I say this is matrix A and let's suppose this is matrix B, they are also not equal because this 3 is not equal to 4 and this 5 is not equal to 6. So they are also not equal. So it has to be of the same order and each element should be equal, right? Another example, if I would say, very typical example given, it's let's suppose this and this. These matrices are also not equal because 1 is not corresponding to 4 and 2 is not corresponding to 5. So this would mean the equality of matrices. So suppose you're understanding this point over here, guys. So that'll be about this video. Thank you very much for watching this video, guys. And in the future videos, we're going to be talking about operations on matrices and everything. And before we go ahead, just make sure that you note down this website, that is perfect-scores.com. You can, there's a lot of exciting stuff on this website. Just make sure that you explore this website. You can ask me questions on the forum. So the forum is there where you can actually ask me questions. And this would be the Facebook page to give us your valuable like. And this would be the email address to give us your valuable feedback. So this would be about this video, guys. Thank you very much for watching. I'll see you in the next one.